Have you ever imagined combining fresh Muscat grape and Jasmine Kombucha into an ice cream? Our group explored this idea and developed a unique frozen dessert called Muscat Grape Jasmine Kombucha Ice Cream. This product combines the sweetness of Muscat grapes, the floral aroma of Jasmine Kombucha, and the creamy texture of an ice cream to create a refreshing and distinctive dessert. The aim of this product was to develop an ice cream with desirable physical properties while maintaining an appealing flavor, texture, and appearance. To evaluate the quality of the product, we conducted several analyses, including rheological analysis, viscosity analysis, color analysis, and phase transition analysis to investigate its freezing behavior. Although texture analysis can provide useful information on hardness and firmness, it was not performed in this evaluation because available texture analyzer condition was not suitable for obtaining consistent measurement for our ice cream. Before conducting the physical analysis, we first prepared the Muscat Grape Jasmine Kombucha ice cream. The ingredients used were 480 grams of full cream milk, 240 grams of whipping cream, 130 grams of sugar, 135 grams of fresh Muscat grapes, and 70 grams of Jasmine Kombucha. First, the Muscat grapes were thoroughly washed and prepared. The grapes were then blended together with the full cream milk and a portion of the sugar until a smooth grape mixture was obtained. Next, the whipping cream was slightly whipped until it becomes slightly thick and fluffy. It was important not to whip the cream to stiff peaks, as a soft and airy texture was desired. The grape mixture, remaining sugar, and Jasmine Kombucha were then added to the whipped cream and mixed until a smooth and homogeneous mixture was formed. The mixture was then filtered through a fine mesh strainer to remove any grape pulp or coarse particles, ensuring a smoother texture and more uniform consistency in the final ice cream. The final mixture was poured into a freezer-safe container and frozen for approximately 8 to 10 hours, preferably overnight, until a semi-solid ice cream structure was formed. After freezing, the product was ready for evaluation through various physical analyses.
The developed ice cream possesses several important physical characteristics that contribute to its overall quality and consumer acceptability. First, it has a smooth and creamy texture due to the combination of milk fat and whipping cream. The fat content helps create a rich mouthfeel while also contributing to the stability of the ice cream structure. Second, the product exhibits moderate viscosity before freezing, allowing the mixture to remain homogeneous without rapid phase separation. This characteristic is important because it helps ensure a uniform distribution of grape particles, sugars, and dairy components throughout the formulation. The ice cream displays a yellowish-green color contributed primarily by the natural pigments present in Muscat grapes. This distinctive color provides visual appeal and reflects the fruit-based nature of the product without the need for artificial coloring agents. Fourth, the product demonstrates a semi-solid structure after freezing, which allows it to be scooped easily while maintaining its shape. The presence of sugars and dissolved solids helps control ice crystal formation, contributing to a softer and more desirable texture. Finally, the incorporation of Jasmine Kombucha provides a slight acidic note that balances the sweetness of the grapes and sugar. In addition to enhancing flavor complexity, the kombucha contributes a subtle floral aroma that complements the fruity characteristics of the Muscat grapes. Overall, these physical characteristics indicate that the formulation successfully combines desirable texture, appearance, stability, and flavor, resulting in a unique and appealing frozen dessert. Biological analysis was performed using a rheometer to evaluate the flow behavior of the Muscat grape Jasmine Kombucha ice cream mixture. As shown in the graph, the viscosity of the mixture decreased significantly as the shear rate increased from approximately 0.1 to 100 per second. Specifically, the viscosity decreased from about 1,680 millipascal seconds at low shear rates to approximately 32 millipascal seconds at high shear rates. This behavior indicates that the mixture is a non-Newtonian fluid and exhibits pseudoplastic or shear thinning behavior. In other words, the mixture becomes less viscous when more force is applied. This property is advantageous during ice cream production because the mixture remains thick enough to maintain stability when at rest, but flows more easily during mixing and processing. The observed rheological behavior can be attributed to the interaction between milk proteins, fat globules, dissolved sugars, and Muscat grape solids within the formulation. Therefore, the rheological results indicate that the product possesses suitable flow properties for processing and contributes to the development of a smooth and creamy texture. Viscosity analysis was conducted using a Brookfield viscometer to determine the resistance of the ice cream mixture to flow. Based on the results shown in the table and graph, the viscosity was approximately 300 centipoise at a speed of 20 rpm, decreasing to 126 centipoise at a speed of 100 rpm. Although a slight increase was observed at 60 rpm, the overall trend shows a reduction in viscosity as speed increased. This supports the rheological findings that the mixture exhibits pseudoplastic or shear thinning behavior. The moderate viscosity observed in the formulation is beneficial because it helps maintain a homogeneous distribution of grape particles and other ingredients while still allowing efficient mixing and aeration. The viscosity is influenced by the presence of whipping cream, dissolved sugars, and blended Muscat grape pulp. Overall, the viscosity results suggest that formulation possesses suitable consistency for ice cream production and contributes to the final product quality.
Phase transition refers to the change in the physical state of a substance. In ice cream production, the most important phase transition is the change from the liquid phase to the solid phase during freezing, as shown in the phase diagram. As the temperature decreases, the ice cream mixture crosses from the liquid region into the solid region. During this process, water molecules begin to form ice crystals, while milk fat partially crystallizes to create the structure of the ice cream. The sugar in our formulation lowers the freezing point of the mixture. This means that not all of the water freezes, leaving a portion of unfrozen water. As a result, the ice cream remains softer and easier to scoop instead of becoming a hard ice block. In addition, the dissolved solids from the Muscat grapes and Jasmine Kombucha further influence the freezing behavior by reducing the amount of ice formed. Overall, the phase transition during freezing produces a stable frozen product with a smooth texture that remains scoopable after storage. Color analysis was performed using a colorimeter to evaluate the appearance of the Muscat grape Jasmine Kombucha ice cream. The major color values were L star equal 33.0, A star equal 2.9, B star equal 5.5, C star equal 6.2, and H degree equal 62.6. The L star value represents lightness and a value of 33.0 indicates a moderately light appearance rather than a bright white color. The positive A star value of 2.9 indicates a slight red component, while the positive B star value of 5.5 indicates the presence of yellow tones. The relatively low chroma value of 6.2 indicates that the color is not highly saturated. giving the product a natural appearance that is consistent with fruit-based ice cream formulations. In addition, the hue angle of 62.6 degrees falls within the yellow-green region of the color space, confirming that the measured color is consistent with the expected appearance of Muscat grapes. Overall, the color analysis confirms that the product possesses a distinctive yellowish-green appearance that reflects its fruit-based formulation and enhances its visual appeal to consumers.
During the development of the Muscat Grape Jasmine Kombucha ice cream, several challenges were encountered in achieving the desired physical properties. One of the main challenges was the formation of large ice crystals during freezing, which can result in a coarse and icy texture rather than a smooth and creamy mouthfeel. To address this issue, an appropriate amount of sugar was incorporated into the formulation, as sugar lowers the freezing point and helps reduce ice crystal growth. Another challenge was the potential phase separation between the grape pulp and dairy components, which could affect product uniformity and appearance. This was minimized by thoroughly blending the ingredients to produce a homogeneous mixture with suitable viscosity. In addition, the inclusion of Jasmine Kombucha introduced acidity, which, if present in excessive amounts, could negatively affect flavor balance and potentially destabilize dairy proteins. Therefore, the kombucha concentration was carefully controlled to provide a pleasant floral aroma and slight tanginess without overwhelming the product. Color stability was also considered, as the natural pigments from Muscat grape may gradually fade during storage. To preserve the product's visual appeal, fresh grapes were used and exposure to air was minimized throughout preparation and storage. By addressing this challenge through formulation and processing adjustment, the final product achieved the desired texture, stability, flavor, and appearance suitable for consumer acceptance. Our Muscat Grape Jasmine Kombucha ice cream is suitable for consumers seeking a functional frozen dessert with probiotic potential. The incorporation of Jasmine Kombucha introduced fermented ingredients and bioactive compounds commonly associated with fermented foods, while Muscat grapes contribute natural fruit flavor, sweetness, and color. Compared to conventional ice cream, this product offers a unique combination of sensory enjoyment and functional food concepts. The balanced sweetness, creamy texture, refreshing grape flavor, and delicate floral aroma create an enjoyable eating experience, while the kombucha component enhance the product's distinctive character. In addition, growing consumer interest in probiotic and fermented foods has increased demand for innovative products that combine health-related attributes with sensory appeal. Therefore, this product successfully combines the indulgence of ice cream with the potential benefits associated with fermented ingredients, making it an attractive choice for modern consumers.
The result obtained from meteorological, viscosity, and color analysis demonstrated that the Muscat Grape Jasmine Kombucha ice cream possessed desirable physical characteristics suitable for consumer acceptance. The formulation exhibited pseudoplastic flow behavior, appropriate viscosity for processing, and a distinctive yellowish-green appearance that reflected its fruit-based composition. In addition, observations during freezing showed that the product was able to form a stable semi-solid structure while remaining scoopable, indicating suitable freezing characteristics for ice cream production. Overall, the combination of Muscat grape and Jasmine Kombucha successfully produced a unique frozen dessert with appealing texture, flavor, and appearance. Although several challenges were encountered during development, appropriate formulation and processing strategies enabled the production of a stable, high-quality product. Therefore, this study demonstrates the potential of incorporating kombucha and food ingredients into an ice cream formulations to create innovative products that combine sensory appeal with functional food concept. Future studies may further evaluate texture profile, melting behavior, and probiotic viability during the frozen storage to provide a more comprehensive assessment of product quality.